All right, so we are starting chapter 3. Chapter 3, just to give you an overall idea of the focus of the chapter, is called Applications of Derivatives. So chapter 3 is really saying, okay, now we know how to take a bunch of derivatives. We have all these rules, but what do they actually do for us? So at no point in chapter 3 will we actually learn any new rules for derivatives. There are more out there. They're coming, but we're going to use the ones that we have for a purpose. Now, the first section in chapter 3, section 3.1, extrema in an interval, you're going to realize a lot of this section is very descriptive. So we're going to talk a lot about what we see visually, what's happening with these different functions. You're not going to have a lot of multi-step questions. In fact, the only thing that will actually have multi-step is the very last video that I make. But it's a lot of just kind of explanations. So kind of hopefully you can listen to this and kind of have some takeaways of just some terminology and things that we know. So the first terminology piece is actually to define what is an extrema. And the word extrema, it's actually plural for extreme, is referring to minimums or maximums on a graph or of a function. So when we talk about our extrema, we are talking both minimum and maximum. First thing you'll notice if you look at this definition, there's a couple key things I want to point out. The actual extrema value will be the y value. So when you're ever asked to find a minimum or to find a maximum, you're actually referring to the y coordinate because that's how high it goes or how low it goes. Now, sometimes they'll say, what is the x value that creates a maximum? So they could ask for that. But if they just say find the maximum or minimum, they are referring to the y value. The second thing I want you to notice is in order to have a minimum, it says that my function values are always less than or equal to f of x. Now, you might be saying, why does it say less than or equal to? Isn't minimum just like the lowest? The reason it has the equals to is there can be ties. You can have more than one minimum. You can have more than one maximum. You can actually have a tie. So you can have two places that have a maximum or two places that have a minimum. It is possible. So that's why it says less than or equal to. And for maximum, it says greater than or equal to. You can have two highest y values. You can have two lowest y values. So I want to start explaining just visually, and you're going to do some visual questions on Delta Math, which tend to be very quick. So if we have an interval and I ask you if it has a maximum or a minimum, what you're going to notice on this first one is it definitely has a minimum right there. And if we're saying we're talking with all of these going from A to B, you could also say that it has a maximum at the ends. So this one, let me put a little dot here. So you could say that this one has a minimum at that low spot, and it actually has a maximum at the beginning and at the end. Looks like those are tied if I just kind of eyeball it. Nice thing on Delta Math is they'll actually give you a grid and a scale so you can see. For the next one, this time we actually have two maximums again. We also have, it's kind of hard to see what's the highest and what's the lowest. It looks like we potentially might have three minimum values. These could all be the same. So we again have maximum values, we have minimum values. Well, then we start to get into the funky ones. So if you look at this next graph, when we talk about maximum and minimum, this one does have a maximum. It is right here. It's the highest point in the interval. But it doesn't have a minimum because the place where it should be the lowest, it's not there. And that's one of the things that has to be true for a maximum minimum. It has to be a defined point. You can't say, well, it's really close to there, but not quite. So the reason this has no minimum is because the place that should be the minimum is not a defined point. We have the reverse happen on this picture. The place that is the lowest is defined. It's right here. But the place that should be the highest point isn't defined. So that's why we say that it has no maximum value, because what should be the highest is an undefined point, is an open circle. And then it's also possible in an interval to actually have neither. You can have no maximum, you can have no minimum, because the points that should be the highest and lowest are not defined. So kind of what your takeaway from this should be is, in order to, first of all, maximum minimums are y values. You can find the x values that create them. You can have more than one. You can have more than one max. You can have more than one min. But in order to be an extrema, it has to be a defined point. We have a theorem. It's called the extreme value theorem. We use a decent amount of theorems in calculus, although no one ever actually makes you like write the name down when you use it, which is kind of nice. You're not memorizing theorem names. And this extreme value theorem says if you have a continuous function on a closed interval, so I want to make sure you know what closed interval means. Closed interval means that the endpoints are included. So that means wherever it starts and wherever it ends are closed circles. If you're continuous and closed, then it's guaranteed that you'll have at least one minimum and at least one maximum in that interval. Now, that minimum maximum could happen at the ends, or it could happen somewhere in between there. But that's all the extreme value theorem says. And it should make sense, because if I have a closed interval and I'm going from one point to another point, either those are going to be the lowest and the highest, or somewhere in that interval, I might get higher and then come lower, but guaranteed you're going to have at least one high spot and at least one low spot. And that's all the extreme value theorem says. It's kind of, we call them existent theorems because they guarantee that something exists. The other thing that you might notice, if you look at these extrema, so here's a maximum value, here's a minimum value. I drew little tangent lines on them. You should notice that at those extreme values, we have a very specific tangent line. We have a tangent line that has a zero slope. So we have a horizontal tangent line, and that's going to come into play as we go through today's lesson. One more slide for this video. So this one, I drew this one. I feel like I'm drawing like a roller coaster. So we have a couple different terms again. There's a difference between an absolute minimum and maximum and a relative minimum and maximum. So your absolute, it's just what it sounds like. It is the highest or the lowest point over the entire either interval or all the real numbers. A lot of times they'll give you like a set interval and saying just in this interval, what's the highest point? That's your absolute. And you still can't have a tie. It is possible to have 2 points that are the absolute highest. Your relative minimums and maximums, or sometimes they're just called relative extrema, are any place that has a peak or any place that has a valley. So what you'll notice here, we have a lot of places in here that are relative extrema. This point right here, it's not the highest point, but if I was riding a roller coaster, it is a place where it kind of turns and starts going back down. So we would call it a maximum. It's just not the biggest one. So that's why we call it a relative extrema. Some books call them local extrema, like it's maximum based on what's around it, but not overall. And you'll kind of see that as I go through. Now with your endpoints can be absolute extrema, and that's it. So right now, when I look at these endpoints, they actually don't end up being either. We'd just say they are neither, because it's not the highest point, it's not the lowest point, but it's also not a peak or a valley. So those don't end up being any type of extrema. Now you can see ones where the endpoints, where you have like a whole bunch of up and down, and then the end. So if I put like this ends up being the absolute maximum, can happen at an endpoint. So your absolute extrema can happen at endpoints or somewhere within the interval. Your relative extrema are only going to happen somewhere within that interval. So it's going to be like you're riding a roller coaster and you hit the top of the peak or you hit the very bottom of the valley. Those are called relative extrema. So you're going to have a few questions on Delta Math that is going to give you a picture and ask you to list the X values that you see extrema happening. And you're really looking for those peaks and those valleys.